Good evening, all. Good evening. Okay, you are welcome to our today's review in pharmaceutical calculations. So the time is 8:37. So we'll stop. Sorry, 6:37 p.m. So we'll stop by 8:37. Exactly 2 hours. So let's see what we can accomplish within these 2 hours. As I told you in our introductory class, I told you that whatever we are going to do here will be a kind of, question oriented, right? Is that what we agree on? So there you ask questions that some things you don't understand. If there's any question that you want us to solve in pharmaceutical, maybe you are trying it and you've not been able to solve that particular question. So this is where you feel free to ask the question, so we can do it together. So I don't know if there's any. If there's no, let's go. Okay, we should not go. I ask.
that proportion. Ratio proportion. That second question.
Okay, which one?
Sorry. The fourth question.
Call the question.
How many fluids are there in 2.5 liters?
Okay, I should start it again. Okay. Remember, in the class, in the lecture, I told you that of course you understood what I said about proportion having two ratios, right?
Yes.
Good. Now, to solve this type of question, you set a proportion. You set up a proportion, and a ratio should contain two terms. A ratio has two terms, right? And the two terms should have the same unit. So it can actually be a ratio. True or false? So it's not when two things have the same standard that you can compare to them. True or false? A ratio is just like comparing the two of them. That this one is higher than this one. Will you come see a pharmacist and say, "Hi, this pharmacist is better than this pharmacy technician"? Does it make sense? Are they of the same level?
No.
A pharmacist is supposed to be. So it's not a big deal when you start saying that a pharmacist knows drug more than this person. He somehow, you should say that for this pharmacist knows drug more than this pharmacist. That one is good. They are both what? Pharmacists. True or false? So that's what we mean by that being the terms being the same thing, being the same. Okay, simply put, they should be in the same denomination. True or false? True or false? Now, if that is the case, now we set up a proportion that will now compare the two, all the terms. If you look at the question says, how many food ounce can we find where? Are there in 2.5 liters? First of all, remember, there's a standard. There is this conversion factor that is common. That 1 fluid ounce is 29.75. I told you about American this thing. But for practical purposes in calculation, we use 1 fluid ounce is equal to 30 ml. But for the purpose of this calculation, let's use 29.75. Are we together? Now, if you watch, 1 fluid ounce is 29.75 what? Ml. But what we are told to convert it to the volume there is in what? Liter. So you cannot directly convert this to liter. You need to convert this to what? Liter. Or you convert the 2.5 liter to what? Ml before it can work. Simple. So if that thing I did, I converted this to what? I converted this to what? Liter. And there is also another relationship that says that 1 liter is equal to what? Would it do this in detail when we enter pharmaceutical what? Measurement. But just know that 1 liter is what? 1,000 what? Mil. Now, if 1 liter is 1,000 mil, you can convert this to 9.75 mil to what? Liter. By setting up a what? Proportion. Or simply cross multiply and get your answer, okay? Now, if 1 liter is 1,000 mil, what do you think should be? 29 liter do you think should be 29.75 mil? We don't know if you call it what? X. Remember, we can set up a proportion. This over this is equal to what? This over this. 3 of us. And cross, we can set up a proportion 1 liter over X. Now, this S should be in the same liter. 3 of us. It's equal to 1,000 mil over what? 29 point. If you watch now, mil is the same thing with mil here. You now find S. If you come multiply, that's what was why this thing will simply give you this 2.975 divided by what? 1,000. 3 of us. And if you divide it, you get what? You put it here. 0. What? 0.2975 what? You see now they are not in the same units. 3 of us. You can now find food downs here. It's not true. We don't know what it means in food downs. We call it what? X. We will call multiply. It's not true. And if you do that, we now find the actual value of what? X. That if you like, you move the 25 liter. Sorry, what am I saying? This thing, sorry. We have moved it to what? Liter. Let me look up. So here that means 1 food ounce is now equal to what? How many liter? 0.0 what? 275 mil. Remember? Right? Now, liter. But the volume we are given is 2.5 liter, right? Yes. So you put it here because they have the same what? Unit. It's not true. It's now equal to what? X. You can find that X. X is now what? 1 fluid ounce times what? 2.5 liter over what? 0.0 what? 275 liter. The liter will cancel liter. We are left with what? Fluid ounce. Handle the number and get your answer. Is it clear now? Now, if you like, instead of moving this fluid ounce, this 2.9 to 9.75 mils, instead of moving it to liter, if you like, you convert that 2.5 liter to what? Mil. If you like, you can convert the 2.5 liter to what? Mil. And remember that 1 liter is 1,000 mil. So 2.5 will be how many? It should be how many? Just if 1 liter is 1,000 mil, X is what? 2.5 liter is X. Cross multiply and find S. What's the answer? No. Look up. I think that's where this lies now, right? We first move. You understand what we did here? We moved the mil to what? Liter, right? Now we want to move the 2.5 liter to mil. Look at it. 1 liter is what? 1,000 what? Mil. But we have 2.5 liter. Is that equal to what? X. Find S. You cross multiply, right? You have what? The S is what? This times this. Divided by 1 liter. It's not true. You have 2.5 liter times what? 1,000 mil over what? 1 liter. 1 liter will cancel liter. The answer is now 2.5 times 1,000, which is what? 2,500 what? Mils. It's mils. So now, we now put it here. We put that 2,500 mil here and find S in fluid ounce. Check it. Check 2,500 what? Mil. Multiply it, find X. What's the answer? Huh? 0.003. Is that answer right? So either way is okay. What matters is that you should ensure that all the terms are in the same. The terms of a ratio should be in the same unit. Simple. Whether both of them are in male or whether both of them are in liter, it doesn't matter. Is it clear? In this first instance, both of them are in what? Liter. But in the second instance, both of them are in what? Male.
I said the term of the ratio should be in the same.
The same unit. The terms of a ratio should be in the same unit. That's why they can actually be a ratio. Any other one? Bring it on. That's why we are here. Get out of Goa. Come on. Ocha Zebia. That means the Russian may have gone now. Okay, everyone Russia.
Sir, can we this question?
How are you?
Sir.
What's that? Yes. Which course subject do you want to do?
Okay, it's not all.
Oh, let me know the subject we are interested in. You cannot do all the subjects in the whole world now. Which subject are you interested in?
The subject that I want.
Mm.
Okay, they want to do.
Math. Okay, we do English, maths, chemistry, physics, and biology here. English, maths, chemistry, 5 subjects.
Like one subject you don't
Huh?
One subject.
It's 2,000 naira. Yeah, it's 4 months, 1 subject. So if you want the 5 of them, it's 10,000 naira. So it depends on you. And check yourself. We start at 4 p.m. here.
Every day.
Monday, Tuesday, Thursday, Friday, and Saturday. Just date of the week with the exception of Wednesday and Sunday. 4 to 6 p.m. here. So tomorrow is 4 p.m. All right. You're welcome. Now, is what? One foot dance. Okay. I think we are done with this, right? Okay. Sorry for the distraction. I need to attend to her.
Sir, see this question.
Call it.
Is to X.
Huh?
Mine is to X.
I'm coming. Let me clean the word. Let me get something like it. Oh, get that one, or even this rag here can serve. Easy to clean. Okay, there. This one is estimation. 5641 plus 2177 plus 294 plus 8266 plus 3503. Now look at this thing. If you like, you can use the method in that course material by looking at these things and look at the average they can give you. Am I completing? If you look at this now, if you use your eye and look at, it's estimation. If you look at this thing now, you try the likely average you can get if you add this whole thing. Now, if you watch this one is in 556. This one is 2. This is what? 2 plus. Okay. Now, see what you will do now. Look at this thing now. If you check this thing now, you see that this thing, look at the second we are done with the first digit is okay with us, right? Now, but look at the second digit. Anyone that is not up to, that's up to 5. You do what? Good. Now you can roughly call this thing. You can roughly call this 6,000, right? Right? Roughly, right? You can roughly call this one 2,000, right? You can roughly call this one what? 300. You can roughly call this one what? 8,000. You can roughly call this one what? 4,000. You can now simply add 5,000. Even in your head, just in your head, sharp, and estimate what it should be. Be calculating calculate the actual value. You focus on this. Focus on 6,000, 2,000, 300, 8,000, and the what? And the what? There's something that I want to let you know. No, you can't call it 4,000. Watch out, look up. You can call this 3,500. Remember, true of us. You can call it what? 3,500. It's not bad. Okay? You can call this, you can simply call this. Even this one, you can call it 8,300. True of us. You mustn't use the first digits. You can call this one what? Let's call this what? 8 what? 8 what? 3. You can call this 300. You can call this 2,000. It's okay. It's not bad. Or even 2,200. Say. True of us. You can call it what? 2,200. If you like, you can call this one 5,700. True of us.
No, 5,400.
Sorry, 5,600. Sorry, 5 what? 6. Sorry, 5 what? 6. You can easily add up this thing without even punching a calculator, or you can punch a calculator without punching a calculator. Here is 2,000. Here is 6,200. Watch out. If I'm doing this, I don't need a calculator. This is 7,000. Add those in what? 1,000 first. 2, 7,000, 15,000, 18,000. 18,800, 19,100, 19,400, 19,900, 19,900. It's a good estimation. What is the actual value?
19,800.
One what?
19,800.
It's a good estimation.
What about
600? It's not bad. But this is perfect. Am I communicating?
Yes.
It's perfect. Just look at it. It's an idea of what the answer should give you.
So what if in a case where the first value is 0.0726?
Come on, write it. Anything you are just writing on board, then we'll take it from there. Because the more you write it, the more it enters, even you that is even writing it. Are you aware? That's why I prefer you to write it. Okay, okay. Let's estimate this. But hope this one is clear.
Yes.
Okay. Let's estimate this one. If you look at it, this is 0.0726 times what? 6,951. Now, what you simply do is this. Let me give you the simplest clue. Move this to standard form. So you can have a whole number that can compete with this. And after you bring back the index form back to the equation and get your answer straight. This one doesn't cost much. And if you do decimal movement here, you get your answer straight. And I said, avoid point. We want to remove these decimal points. Have 726. and now work with 726 and 695. We now work on it and get the answer. If you look at this now, remember our decimal movement. If you want to get 726, what do? We move, right? 1, 2, 3, 4. We move 4 decimal movement to the what? Right. So if we move 4 decimal movement to the right, what will be on top? Negative what? Negative what? 4, right? Negative 4. So this is now saying 9. So this thing is 4 minus 4 now. So you don't, when you're done, you bring it back. You have what? 726 times what? 695. You need to be careful because if you get Zocha, forget everything. Am I communicating? Now, you can put it in one year, but I just wanted to keep it aside. Now let's look at this number. Let's look at this number. 726. Let's estimate this. We can get 73 here, 3 of us. And if you get 73, this will become 0, right? It will add 10 here. Hope you know. Do you agree? Because this setting is saying 73 times 3 is power 1. But 72.6. This setting is saying 72.6 times 3 is power what? We move to the left 1. And if you move to the left, it will add positive because you're moving to the left. Positive 1 is 3 is power 1 is what? 10. 2 of us. That's why I say you get 73 here and add 10 here. Is it clear now? So here is what? 73 times 70. If we do like this, 1, 2, right? 1, 2, right? And if we call this 70, what will happen here? Here is what? 1, 2. About 70. It will stop here. I hope you know. If you move here, it becomes 7. Are you aware? So if you pick 70, the decimal point will stop here. Are you aware? And if you stop here, now you move what? 1, 2. So plus 2. So you add 3 for what? 2 here. 3 of us. So you now get something like this. 73 times what? 70. Does it make sense? What is it? Why are you confused? Let me understand.
That the second one, 6, 9.
This 9 is up to is 5 and above. You can call it 0 and add 1 here. Actually, this will become 7,000. Actually, are you aware? Let me not confuse. Let me say. In fact, wait. Let me even show you something. Let me do it in a way that you understand better. Let me follow this. I think that this is what is confusing you. Let me. But you agree with me that don't worry. Let me do something. That's something I want to do now. Oh yeah, let's walk it straight. Bam. Look at this now. Do you agree with that? If this is 0, this is 3. This is certain as saying 730. Do you agree with me?
Yes.
Times what? 7 what? 1,000. Do you agree with me? Remember, it's estimation. You can simply multiply. But remember that we only for this 726, we only have things for what? Are you aware? If you multiply this, if you multiply this, you get the answer. But if you want, you start eating up this minus 4 will start eating up these zeros. 3 of us. If minus 4 here, eat 1 0 here. Here you come down to what? Minus 3, right? And if you eat another 0 here, minus 2, right? If you eat another 0 here, minus what? Then it will eat this 0. Of 3 is 4 what? 0. Which is what? 1. It will go. So we are left with what? 73 times what? 7. I do 73 times 7. What is the answer? 511. That's the answer. Is this one clear? What if what happened? Is what?
490.
You got 490 as your estimate. It's not bad. It's okay. It's not bad. Let me go and sit down. Yeah, come and ask more questions. Ask questions. Okay, 1/1000 is to what? 1/100 as what? X is to what? It's the same thing we did here, right? You understood that thing we did here, right?
Yeah.
About ratio and proportion, right? This is first term of this ratio, second term of this ratio, this first ratio, this is second ratio, the first term of the second ratio, and the what? 30 is the what? This as a ratio. This is first ratio, second ratio. Inside first ratio, 1/1000 is the first term of the what? First ratio. While 1/100 is the second term of the what? First ratio. If you go to the second ratio, X is the first term of the first ratio. While 30 is what? Second term of the what? The second ratio. Then, but if you want to read it as a proportion, 1/1000 is the first term of the what? Proportion. 1/100 is the second term of the what? Proportion. X is the third term of the what? Proportion. 30 is the what? Fourth term of the what? Is it clear now? So if you now want to do this now, you simply do what? Put it this in fraction form. You have 1/what? You have 1/what? 1000, right? Divide by what? 1/what? 100 is equal to what? X over what? 30. Remember our rule of fraction. In division, this one will do what? Turn. Right? So you have 1/what? 1000 times what? 100/what? 1 is equal to what? X over what? 3. This will cancel this. So that means 1/what? 10 is equal to what? X over what? 30. So we are looking for what? X. So you cross multiply. X is now equal to what? X times what? 10, right? Is equal to what? 1 times what? 30. So X is now equal to what? 1 times 30 over what? 10. So X is equal to what? 3. Is it clear? Good. Don't forget what I say, that what you are doing here, say any topic you want, you get question for, I'm solving it. They are nothing like topic by topic. That's what we agreed. It's not true. So get question. No, you don't even need to talk. As I'm finishing this one, go there, write another one. So far October 8:37. So just go there and write another one. Let's solve. That's all. If I do that as if you didn't prepare any question. Before coming here, you'd have gathered questions you want to ask.
Sir, answer that third quiz. Some of the questions, you see, majority of the questions, almost 90% of the questions.
Is that a question? All right, let's look at the question. The question says, if a multi-dose liquid medication contains 100 ml, the patient takes 5 ml per day, how many days will the medication last? Listen, when it comes to dosing, there's what is called multi-dose and single dose. If you hear multi-dose, if you hear single dose, it means that once you put the container, if it's when you are drinking, you just drink it that once. That's the end. You finish it at once. Now, there are some drugs like that. Like now, warm drug for albendazole in suspension form. That's small thing. They take it at once. It's a single dose this thing. It's 20 mil. You just take the whole 20 mil. That's all. Then there are some drugs like if you go to and buy cough syrup now, if you open the cough syrup, use spoon, 5 mil spoon to collect it for the baby, or 10 mil as case maybe for adults. Every day you go there, take. In the morning you take, cover it well and keep. In the afternoon you take again, cover it well and keep. In the night again, tomorrow again, like for like 3 days. This is a multi-dose liquid what? Multi-dose what? Liquid medication. Is it clear? It's multi-dose because you take different doses. More than one doses. Once you can take more than one doses from it, it's no longer a single a single dose or unit dose. Am I now with that background knowledge? Let's solve this question. If a multi-dose liquid medication contains 100 ml, so in that bottle, this is the bottle. The bottle is what? Inside the whole bottle is what? The volume is what? 100 ml. And you are told that the patient takes 5 ml per day. 5 ml per day. So, how many days will the medication last? Now, if the patient takes a meal per day, so our units now, proportion we want to set now, we have this unit, we have day and meal. True of us, day and meal. Now we have what? Day and what? Meal. We have 5 meal. We have 100 meal. True of us. We have 5 meal. We have 100 meal. Now we have 1 day. What of the remaining day? True of us. So we can now get the ratio that is complete here is now meal. Has the unit of meal. True of us. The complete ratio we have here now is meal. So that means 5 mil is to what? 100 mil, right? As this day now, 1 day, a day, per day. Which one does it have a relationship with? 5 mil. So that means 1 day should come first here. 1 what? Day. Is to I am as in cause, right? X. Is it clear? So we now put it in fractional form. You have what? 5 mil over what? 100 mil is equal to what? 1 day. Please, your unit is very important. Over what? X. So we now find X. Our X is now equal to what? 100 mil times what? 1 day. Over what? 5 mil. Mil cancel mil. Days remaining. 5 divided 100 is what? 20. 20 times 1 day is what? 20 days. So it will take 20 days for the 100 mil to what? Finish. You can also solve this with dimensional analysis. Are you aware? You can solve it with dimensional analysis by just aligning the units. Do I try it? Yes. So let's solve it with dimensional. Let's align the units. Remember, in dimensional analysis, I said that the unit you are looking for, write it and put question what? Mark. Now look at the question. Which unit are we looking for? Look at the question. Look up. From this question, which unit are we looking for? Days, right? So we put what? And put question mark. We put what? Days and put what? And put question mark. You put here what? Days and put what? Question mark. It's equal to. The first thing that will appear is the one you are given that you are looking for the other side. Which one are you looking for? Is companion? A male. Which one are you looking for? Is companion here? 5 mil has a companion.
Okay,
100 mil, good. That should come first. So 100 what? Mil should come first. Now, the next thing you will do, what are we going to? Remember, we have a what? Look at this question. There's already a commercial. There's already a commercial factor here, right? True of us. We have 5 mil is for what? Or is there's already a ratio? Yes, sorry. 5 mil is for what? Or commercial factor. Anyone call it. 5 mil is for what? 1 day. So how do we align this to cancel mil? To cancel mil, which one should come on top? No, we only have 100 mil over 1. I'm talking about this relationship.
1 day.
Good. Times what? 1 day over what? 5 mil. Mil will cancel mil. 5 will cancel 100. 20 will remain. 20 times 1 day is what? 20 days. 20 days. That is dimensional analysis. Is it clear?
Yes.
Okay, so it's actually what? 20 days. And to cut every steps, maybe fast, but you don't want to waste time. You just simply divide 100 mil by 5 and get your answer. Are you aware? But it's good to explain this so you know how we arrive at that what? 100, because there are some people that will just, that's why some people fail this calculation. They will think that it will always, there are some systems, that's how they will set this question. The answer you get the answer by multiplication, true of us. So what matters is to understand how to set up a ratio.
So I have a question.
Ask.
So if this 100 is not new, what if it's new?
Nice question. Okay, can you ask the likely question that may come out? Can you frame a question with that you said now?
And then just change the unit.
Change it, which one?
That 100
to liter. And you want to find what? The days it will last, right? Good, I like that question. Now look at it now. I will solve it to this now. And this will warrant to set up two proportions. Okay? Let's assume that what we have here is what? 100 liter. And you are told that even though 100 is a very large volume, but it's not obtainable. That listen carefully. It's not obtainable that you see a multitude drug that one person will take 5 minutes. Do you know how many days you take to reach 1 liter, 100 liter? But let's just solve it as we are solving something. For you to learn stuff, not that it's practical. Okay, 1 liter. You're taking 5 minutes. How many over 5 minutes? It's too much. But let's just solve it to teach you something, okay? Now, let's assume this thing is 100 liter. And the person will take 5 minutes per day. Now, see what will happen. Using normal proportion, you will set two proportions. The first proportion you will set is this. You have already been told, let's look up. You have already been told that 5 mil will be taken per day. So all your attention is to move this 100 liter to what? Mil. So it can be the same thing, right? Now, you know that by standard, you know that 1 liter is what? 1,000 mil, right? 1 liter is what? 1,000 mil. If 1 liter is 1,000 mil, 100 what? Liter is what? X. You set a proportion. Therefore, 1 liter over what? 100 liter is equal to what? Mil over what? X. Is it clear? Find X. Cross multiply. X is now equal to what? 100 liter times what? 1,000 what? Mil over what? 1 liter. True of us? Liter will cancel liter. 100 times 1,000 mil is what? 100,000 mil. Have you seen why I said that this is not possible? How many years you can go? 5 mil. Before you drink up to 100,000 mil. Years. It's not even much. Then it's no longer a liquid preparation because you cannot drink 5 liters. With drug. No. These things I'm just see. You know, these things I'm just pointing. We can just use it to learn something. But I'm pointing out a real situation. It's not possible. But what your calculation is correct. It's not wrong by calculation. With this, if you understand this, no matter any number they gave you, you see, even when you are working, you can do your calculation properly. The basis is to understand what you are doing. But I'm just trying to point out something that this thing is not obtainable in real world life. Because there's no drug you keep opening the bottle and close it for years. It will contaminate the two of us. So I'm just trying to explain something. Now with this, we have gotten X. We have set the first proportion and got X to be what? 100,000 mil. Now let's set the second proportion. Look at it here. Watch. 5 mil is for what? Is for what? 1 what? Day, right? Then 100,000 mil is now what? We don't know. We call it X. So we set the second proportion. We have 5 mil over what? 100,000 what? Mil is equal to what? 1 day over what? X. We are looking for X. So if you cross multiply, X is now equal to what? Tell me. 5 mil times what? No. X is what? Check well. 100 what? 100,000 what? Times what? Check well now. 6 multiply. This times this is equal to this times this. True or false? So it's 100,000 mil times what? 1 day over what? 5 mil. So mil will cancel mil. 5 will divide 100,000 is 20, right? 20,000. Then 20,000 times 1 day is what? 20,000. You know how many years? This is wrong. Just divide 20,000 by 365 days in a year. Don't know how many years, but tell me how many years the person will take this drug. What about drug is that one? What about drum? Now, we are one big. Do you know how many times the person will form the drug?
5 years.
The person will take the drug for 5 years. How would the bottle look like? But it's just for us to do good calculation, okay? Now, this is what 20,000 what days. Is it clear? Have you now seen how I use normal proportion and pass through different stages, right? Now, with this now, if you use dimensional analysis, see what will happen here. Just in one stress. Watch out. I don't know this one. Right. Let me show you something on that one. Now let's look at this. Let's solve this same thing using dimensional analysis. Watch out. Remember the rule. The first unit you write is the unit you are looking for, right? From this question, we are looking for what? Days, right? So days should come. We have what? Days. Question what? Mark is equal to. The first quantity you write here will be the one you are looking for is companion, right? I use companion for us to understand it. Look at this question. 5 mil per day. How many days will it last? This is the bottle that contains how many liter? No, liter. So we are looking for the companion of what? So 100 liters should come first. So we have what? Over what? Remember, we have two conversion factors here. The first one say that 1 liter is what? Remember, what does that mean? Second one say that 5 ml is equal to what? 1 what? In 1 day. True or false? Now with this, now we can solve this question. Now, which of these can we use to cancel out liter?
1 is
No. To cancel liter, which one? Times what? Check it well. To cancel liter, not me now. To cancel liter, we want to this L to go.
Yes, 1
How place it, align it well. 1 liter, good. We have what? 1,000 watts, mil over what? 1 liter. Times, in trying to cancel it, we have created another problem. We want this meal to go. So what can we do to this for me to go? 1 day over what? 5 mil. We are good to go. So let's cancel out. Liter will do what? Mil will do what? Multiply the numerator and divide by the denominator and tell me the answer. 20,000 days, right? The answer is what? Have you seen how straightforward dimensional analysis can be if you understand it well? But this one will find this before that last one I saw in the class. 3. If you follow this thing, you set 3 proportions. If you like, if you watch, I listed 3 conversion factors before I started solving it. So that is the answer. So it's possible that it can be in under units, provided that they have relationship. Telling me just write it there. While solving, I'll be explaining it. Well, what I'm going to make it, that is not the question. Is that the question? Okay. Okay, look at this question. The question said, this thing means that T is inversely proportional to what? No, A. That's the meaning. You know, I told you we have different proportion, different variation, right? Inverse variation is shown like this, that if A is like this, sorry, let me use this T and A. T like this. This means that T is directly proportional to what? What do you mean is that as T is increasing, A is what? Increasing. That's direct proportion. Directly, as T is increasing, A is increasing. This is the direct proportion. This is sign of proportionality. But if they are like this, it means direct proportion. Now, if we have T like this, 1 over what? A is inverse. What it means that as T is increasing, A is decreasing. And as A is increasing, T is what? Decreasing. Is it clear? Is it clear? Now, with this this is inverse what? Proportional variation. Now, let's solve this question. See how you solve this question. Now, another point I want to make is this. You know that this is just a sign of proportionality. If you want to remove this sign, you will introduce sign of equality. And for you to introduce sign of equality, a constant must come in. So if you put sign of equality here, you can call it, normally we normally use K as constant, normal, in most calculations. So let's use K as the what? Constant. What it means is that this implies that T is equal to what? K, A. That's the meaning here. And this one implies that T is equal to what? K over what? A. Is it clear? Because if you separate this now, this look like K dot what? 1 over A times 1 over A. That's just the same way we did this one now. But K times 1 is now K. That way is what? K over A. Let me stop here so I can solve this question. When we get questions that has to do with other variation, I will talk about them, okay? So this is this, okay? Yes. Now with this, we can solve this question. Now, if you want to solve the question like this, so that means we are using this first one, right? So second one. Let me print the first one so it doesn't confuse us. So this implies that T is equal to what? K over A. Now, there's what is called formula. There's some question you will see. The question will ask you, what is the formula connecting T and A? In order to be able to solve it, what you do is, let's first of all use the first value of T and A to find the constant. Is this A or D? Not A, right? Okay, so let's change it, please, so it doesn't confuse us. Is D, right?
Yes.
Good, not A. So here is what? D. Is it A?
No, it's D.
Can you put A? So it's D, right? Now look up. They are giving us the first value of T, first value of D. We use the first value of T and first value of D to find what? K. True of us? From this equation, we find K. So if we now find K, we put K back to this formula and find the equation, the formula connecting T and D. Let me solve it so you understand. We have done, you know how we got to this place, right?
Yes, sir.
So at first instant, remember that T is equal to what?
0.15
So that means 0. What is equal to what?
Okay.
K over what?
D.
D. D is what?
120.
1 what?
Yes.
20. So let's find K. We cross multiply. Right? So K is now what? 0.15 times what? 120, which is what? 0.15 times 120. This will give you what? 1, 2. 18, right?
Yes.
So K is what?
18.
You have found the constant to be what? 18. What you do is introduce this K back to this formula now. So that means T is actually what? 18 over what? D. This thing now is the formula connecting T and D. With this thing now, any value of T, you can find corresponding value of D. And any value of D you are given, you can find the corresponding value of T. The question said find T when D is 45. It's simple. Simply put 45 for D and find what? T. Is it clear?
Yes.
So when D is 45, this is the formula. Sometimes they may ask, there's some question you will see, they will stop at this place. They will ask you formula connecting the two of them, or the relationship between the two of them. In such case, stop at this level. You have gotten the answer. Now, but this one, they want you to find T. So, but this is the formula. Connecting what? Connecting what? T and what? D. That's the formula. But now you are asked to find what? T. So because you are asked to find T, you now start saying when D is what? 45. That means T is now equal to what? 18 over what? 45. What's the answer? 0.9, share? Because 0. What?
0.4.
This is 3 is what? 6 over 15, right? 6 over 15. This is 6 over 15. Let's get all the whole fraction. This is 6 over 15. This is also what? 2 over what? 5. 2 over what? 3 divided 18, 6. 3 divided 45, 15. 3 divided 6, 2. 3 divided 15, the equivalent fraction, 3 of us. So 2 over 5 is what? 0. What?
4.
0.4. So the answer is what? 0.4. No, remember, leave it where you, how they ask you. That's 0.5, 1.5, 0.115, leave it at that. Okay? I don't mean here is a fraction, leave it in fraction. As a common fraction, leave it in one fraction. So the answer is what? 0. So when D is 45, T is what? Watch out. Let's check whether it's actually true. Whether T is increasing, why D is decreasing. Watch out. First instance, T is 0.15 when D is 120. The second value of T is what?
0.4.
Did it increase?
No.
0.15.
Yes.
T was initially 0.15. Now it's what?
0.4.
So it increased. What of D? D was initially what?
120.
What happened here?
Decrease.
It decreased. So it's an inverse what?
Proportion.
The patient's height 20 inches, weight 51 pounds, dose 75 milligram per meter squared. The BSA, what's that?
5
Okay, sorry, 5 pounds. Sorry, that LB is pound. 5 pounds. Dose is 75 milligram per meter squared. The BSA and milligram per dose are, BSA means body surface what? Area. And to be able to determine that, there's something I want to. Do you have meter rule here? There's what we call a nomogram. Nomogram is used to calculate the BSA. In calculating dose, there are different methods of calculating a patient dose. Dose a patient can take. We have Clark's rule. We have what's them again? We have Clark's rule. Then we have this rule again. What's them again? The one that uses the age, and the one that uses age, weight is involved, and the BSA use both the body surface area. But for you to calculate the body surface area, you will need the patient's weight, height. That's how you trace it in the nomogram. For us to be able to do that, we need to trace it. The question is there any graph there? We trace it using our ruler. We use our ruler. If you open that very well, you see that if you use ruler. Let me see if I have ruler here. So you use the first one is Young's rule, Clark's rule, then BSA. Let me see if I have Young's rule, young, as in young.
Okay.
I'm telling you the different formula, different things we use in determining the pediatric dose in the baby's dose, the dose the baby can use. I told you we have Young's rule, we have Clark's rule, then we have use of what? The body surface what? Area. That's what I'm saying. Now this question has a lot to do with use of the body what? Surface what? Area. And I think that the graph, the graph now you use, this thing now is what is, we call this in what? Nomogram. We call it what? Nomogram. So we use nomogram. The nomogram has we have the weights, the heights. That's how you trace it. Where they meet, the body surface area is at the center of them. The weight is this long one. This one, the one at the center is the body surface area. The other one is height, body surface area. So if you trace it, where the two of them, the baby's weight is this, the child's weight is this. You trace it and the exact weight. If you look at the height, this side is cm, this side is inches. If you look at the weight, this side is pounds, this side is what? Kilogram. So if you now check the exact, this is 20 inches as against 5 pounds. You cross it. Wherever it cuts across the what? The BSA part is the child's what? BSA. Is it clear?
Right.
Is the child what? BSA. And the unit of BSA is meter squared. So if you want to get the child BSA using tracing this height and this weight, you get the child BSA. if you know the child BSA, this is 75 milligram dose per 1 meter square BSA. This BSA is measured in what? Meter what? Square. So if 75 milligram is 1 meter square, so whatever BSA you have should be how many watts? Milligram. You get your answer. First of all, you have already gotten the BSA. Does it make sense? So the idea is now, let's trace this thing. Let me see if I have ruler, so you can try it. We can trace it if I have ruler. It's simple now. This ruler has broken. No. Let me see if I have another one. If I don't have ruler here, maybe you keep the question. What if the next time you bring ruler, so we can trace it, okay? But let's see whether this can cross it. Let's see if this can cross it. Once you can cross it, we are good to go. Now, if you zoom it now, they say that the patient's height is what? 20 inches, and weight is what? 5 pounds. Let's use this ruler to check. Where is this side is what? Height, inches. Inches is what? 20 inches. 20 should be where? See 20 here, right? Mm-hmm. We place that, ensure that it's at this 20 dot, right?
Yeah, 50.
This side is 20. See, okay. This side is inches. CIN is inches. This side is centimeter. We are working with 20, not 50. Mm-hmm. We place it here. The weight is in pounds. This side, see the weight side. See the weight. This side is in what? Pound. LB. This side is what? Kilogram. It's 5 pounds. Where is 5 pounds here? 5 pounds is somewhere here. See 5 here. Can you see it? Mm-hmm. We have 20 here. We have 20 here. We have what? 5 here. Can you see it? Mm-hmm. So if you trace it now. If you trace it now. Look at it. Where did they cross here? Let's read this calibration. Watch out. If here is 0.1 and here is 0.2, that means one calibration here is what? How many are they? Don't worry, we can trace it back. Let's calibrate this BSA now. Look at here is 0.1. Here is 0.2, right? So let's count how many calibrations you see inside here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.2 minus 0.1 is what? 0.1. So divided by these 10 divisions, 0.1 divided by 10 is what?
0.1 divided by 10. 0.01.
Good. That means each of these calculation is what?
0.01.
If here is 0.1, here is now 0.1 plus 0.01 is 0.11, right? 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19 and what? 0.2. Confirm. So we have determined that here each division is what? 0.01. Let's go back to what we traced. Remember we traced 20 here, right?
Mm-hmm.
And what?
5.
So let's check where it crossed. This is 5. Let's check where it crossed this thing. It's at what?
0.08.
No. You remember I said it was 0.1. Here it's 0.1 what? 0.1, 0.11, 12, 13, 14, 15, 16, 17, 1 what? 8. So what we got is 0.18 what? Meters square. So the patient's BSA is what? 0.18. Is what? 0.18. 0.18 what? Meter what? Square. 0.18 meter square. That's the answer to the BSA. Now, next question is what? Milligram per dose. Now, if the dose is what? 75 milligram per what? Per what? Per meter square. This is the BSA, right? Per 1 meter square. Now, if 75 milligram is what? 1 meter square, true of us, then the what we got, 0.1 watts, is now equal to what? x. True of us, we set the proportion and find x. So the s is now equal to what? 75 milligram times what? 0.18 what? Over what? 1 meter squared. Meter squared will cancel meter squared. True of us, 18 times 0.75 milligram is what? Sorry, I mean 75 milligram times 0.18 is what? 75 milligram times 0.18 is what?
13.5.
So the milligram the patient will take is what? 13.5 mg. So the answer, they say milligram per dose. So the person per dose is, the person will take how many milligram? 13 what? 0.5 milligram.
So how do you manage the 13.5?
5 milligram, simple. They will ask you milligram per dose. So that means how many milligram will a dose contain? True or false? So it's what? 13.5 milligram. Yeah, yes, you trace it with ruler.
What will you like?
No, it will be in your question paper now. This thing, the nomogram will be in your question paper. You trace it with your ruler and solve it. It will be in your question paper. So paper. 1 hour, 1 hour 15 minutes, 100 questions. It's open-ended question. It's not, no option. Just solve and write the answer. Simple. It's very good time. Okay, the question said that y is inversely proportional to 1 over x and y is 8 when x is 1 over 2. Find x when y is 2. Have you found your k? Huh? Your k is what? Is 4. You got it now. K is 4. So if k is 4, what is connecting formula? What's the connecting formula? That y is equal to what? 4 over x. Correct. Then x you don't know x now, right? So you only know that y when y is 2. Good. You cross multiply and get that x is what? 2. It's correct. It's correct. Then check whether they are actually inversely. Check, just confirm, just confirmation. Initially y is 8, right? When x is what? Half. Right? So when y came down to 2, did x increase? Check where. When y was 8, x is half. So when y came down to 4, what happened to x? Increased to what? Precious. So the variation is in order. And you also got the answer. So the answer is what? 2. You got it. When y is 2, sorry, I mean not 4. When y came down to 4, sorry. X. If you watch now, the extent of change is all descending in the opposite side. Watch out. Y came to half. Y came to from 8 to what? 2. Right? It came from 8 to what? 2. Then x increased from half to what? 2. Am I communicating? You got it. That's the answer. For over x. Simple. They may twist it, they may call it relationship, or it can also be called the formula connecting the two of them. The, the question says, a child, is this two?
Yes.
Good. A child is to receive X grain. This is grain. Grain. When you get to pharmaceutical measurement, we have different units of different system of measurement. We have the metric system, the one we know, kilogram, milligram, and what are for weights. But we have the old system, or call it apothecary system, or avoidable system. Those ones are the old system before this new one, before this metric system came in. So this grain is a unit for weight. Actually, one grain is equal to some use 65 milligrams or what? 60 what? Milligram. 1 grain, 65 milligram or 60 milligram. Am I communicating? But I think this one is preferable, 65 what? Milligram. Okay. Now, he said that a child is to receive X grain. This means X what? This X, sorry, this is 10, not this is Roman numeral, sorry.
Okay.
It's X, okay? Roman numeral. But if we are using grain with Roman numeral, this old method, they should come first before they. That's how they were writing those days before we come to our dispensation. Now, this means 10 grain. This is X Roman numeral, which is 10, okay? But if you are using Arabic numeral, just write 10 what? Grain, okay? But if you are using Roman numeral, it's what? This means 10 grains. 10 grain. As this one is what? 5 grain. It's a unit of 4 weights in those days. So a child is to receive 10 grain of a medication that is available in 5 grain tablets. How many tablets should the child receive? This is a proportional question. This is a proportional question.
10 over 5 grams. Times 5 over 1.
So
That
one
is 1 grain
one-
over 65 milligrams.
yes, no milligram now. You're not converting to milligram now. This is just you are working in that system. You are working in that system. Excuse me. Sorry. This is proportion. Simple. It's proportion. Look at this thing. Don't let this thing confuse you. Just use our normal way of doing proportion. You are told that a child is to receive 10 grain of a medication. And that medication is available in 5 grain tablet. That means 1 tablet contains how many grain?
10.
Listen. Why do you always go to 65? This is just, we are converting from Avoadepo / apothecary to what? Metric. I just give you the conversion factor. They didn't ask you milligram. It should be, just watch out now. What matters is this. From this question, what you need to understand something from this question. That a child is to receive 10 grain of a medication that is available. The one in the shelf is 5 grain tablets. This means that a tablet contains how many grain? 5. Inside the tablet, what the active ingredient inside that tablet is how many grain? 5 grain. What do you mean? So that means 1 tablet is how many grain?
5.
Good. 5 what? Grain. Good. But a baby need to take what? The child needs 10 grain. Which is now equal to what? 10 what? Grain what? 10. But you don't know how many tablets the child will take, right? We call it what? X. So we come multiply, right? We have that X is now equal to what? 1,000. Hope you know that this everything should be in what? No, but whether it's in Roman numeral or just understand that it's one same thing, right? We have what? times what? 10 grain over what? 5 grain. 5 grain divide 10 grain is what? 2 grain. So this is what? 2 what? True or false? So grain has gone, sorry, because grain will cancel grain. So we have 2. 2 times 1 tablet is what? 2 tablets. Yes, that's what I wanted to say. 2 what? 2 what? Tab. I like that. 1 tab. 2 what? So that is the answer. Let me ask a question. I say that this thing, I told you about 2 systems. We have basically 2 systems. Imperial system, let me even name them. Imperial system and what? Matrix system. It's under imperial system you start having this apothecary, avadepo, okay? Now, this grain is used in apothecary / avadepo, depending. But if you want to convert from this old system to the matrix system, 1 grain is equivalent to 65 milligrams. Now, let's assume now, if I now ask you, what will now be 5 grain? A milligram. 5 grain, a milligram is what? If 1 grain is 65 milligrams, so 5 grain is how many milligrams? If 325 milligrams. Is it clear? That is if you are using 65 milligrams. But what if you are using 60 milligrams? It becomes what? 300 milligrams, right? Good. Okay, let's look at this question. The question says, stock 250 milligram tablets, full stop. Dose 125 milligram. Come and give dash tablets. Listen, there's a difference between. I want to talk about the difference between dose of a drug and strength of a drug. Dose of a drug is the amount of drug a patient needs to take in order to take care of to achieve a particular therapeutic outcome. Dose of a drug is the amount of drug taken by a patient to achieve a particular therapeutic outcome. That is the dose of a drug. The amount required by a patient or taken or administered to a patient to be able to do what? Achieve a particular therapeutic outcome. That is meaning of a dose of a drug. Am I communicating? Now let's assume now, as an adult now, if you go and take half tablet of paracetamol, do you think it will really work for you? Sorry, let's say half tablet is 250 milligram, right? If you go and take 250 milligram of paracetamol, do you think it will work for you? But if you, as an adult, you take 1 gram, right? Take 1 gram morning, afternoon, night. If you say before tomorrow, it will be okay, because you took the dose you took as an adult is 1 gram at a point at a time. A dose is for an adult is what? 1 gram. That is what an adult can take before he can take care of the headache properly. That's the meaning of dose of a drug. But the strength of a drug is the amount of drug the manufacturer put inside a particular dosage form. True or false? Let's assume now the amount incorporated in a particular dosage form. Like now, if you get paracetamol now, let's say paracetamol tablets.
So is the amount incorporated in
by the manufacturer in a particular what? Dosage form. What it means in essence is how the drug is presented. Is it clear? Again, what is the strength of paracetamol 1 tablet in the market now? What is strength?
This is the amount incorporated by the manufacturer.
So you can use, I think use concentration. Concentration is better. It's concentration of the drug in a particular active ingredient of the drug in a particular dosage form. I think concentration is better because the amount, by the time we enter concentration now, it will start confusing you.
So it's a concentration of a drug.
Yes, in a particular what? Dosage form. I think concentration is better than amount because they're not the same thing. Use concentration instead of amount. Concentration of a particular what? Drug. You know that drug is active ingredient. I hope you know.
Yes.
In a particular what? Dosage form. That gives it strength. Let's assume now, paracetamol tablet in the market. If you get 1 tablet of paracetamol, 1 tablet contains paracetamol 500 milligram. True of us?
True.
1 tablet contains what? 500 milligram. So the strength is 500 milligram of paracetamol per tablet. Is it clear now? The strength is because it's a concentration. 500 milligram per what? Tablet. That is strength of paracetamol in a tablet in the market now. But I think Emzo has 1 gram per tablet. But the one that is common is 500 milligram per tablet. That is a strength. For an adult, the strength is what is inside, right? But for an adult that has a dose, that adult will need a dose of what? 1 gram. So how many tablets will an adult take to achieve that 1 gram? 2 tablets. So in a day, morning, afternoon, night, an adult needs 6 tablets to achieve the daily dose. What is the daily dose of an adult?
6.
You are confusing strength and dose. What is the daily dose of an adult?
3.
No, in gram amount. You know that the dose is amount.
Okay, 3 grams.
3 gram, good. Daily dose of an adult is what?
3 grams.
How many tablets of paracetamol 500 milligram can achieve that 3 gram in a day? 6. If you know this, you can answer this question. What is there? I don't understand. Tell me.
The question I asked, you said how many milligram?
Yes.
How many gram can an adult achieve? How many doses can an adult achieve?
How many doses of paracetamol does an adult need in a day? Sorry, if I say how many doses, I mean 3 doses now. But how many gram? How many? What is the amount inside that dose that will make up that what? 3 gram. 1 gram morning.
1 gram.
It's 3 doses. Hope you know. But in terms of amount, is what? Well, a dose is 1 gram. So 1 gram morning, 1 gram afternoon, 1 gram. So how many tablets of paracetamol in the market, 500 milligram in the market, can achieve that? If the person now goes to the pharmacy to buy the drug now, and what they have in the shelf is 500 milligram paracetamol in a tablet, how many tablets can achieve that 3 gram for the adults? It's 6 tablets. But let's assume that the adult went to the pharmacy, and what they have in the pharmacy is what? 100 milligram, like I told you about Emerson, 100 milligram paracetamol. How many tablets will the adult take to achieve that?
3.
You see now, this is why people are confusing strength and what? Because an adult need 3 gram, and this company package their own for 1 gram. You will take 3 tablets. You will think that those are strength are the same thing. They're not the same thing. If you understand what I said now, you can answer this question. The stock means, by this stock, it means how the tablet is presented. 250 milligram tablet. What do you mean that inside the tablet you have what? 250 milligram. They didn't ask you the how many tablet. No. They're talking about what is inside that what? Tablet. 250 milligram tablet means the active ingredient in a tablet is what? 250 milligram. But the dose, this is strength. This is what?
Strength.
This question, I want to know whether you know the difference between strength and dose. Simple. This is what? Strength. Good. This is what? Dose. Now, you are in pharmacy, where you work. So what now you go for your IT, where you are working. And the strength of the paracetamol you have in the market in your shelf is what? Or any drug is 250 milligram per what? Tablet. This dose is one written on the prescription for the patient to take. The patient need to take. And somebody comes with a prescription that has a dose is 125 milligram of that drug. How many tablets of this will you give to a patient to achieve that 125 milligram? Check well. Check well. If a tablet contains 250 milligrams, no. You are taking it upside down. The tablet we have is 250 milligrams. And patient needs the dose which is one the patient needs to achieve is the therapeutic outcome is 125 milligram dose. How many tablets will you give to the patient? How did you get to check? Tell me how you got to. Huh? You are confusing strength and dose. The strength you have in this shop. Okay, now let me ask you a question. Let me make it simple. You have a baby, right? And the dose of paracetamol a baby need to take is 250 milligrams. And the paracetamol you have in the shelf is 500 milligrams. How many tablets will you give to the baby? A baby needs 250 milligrams paracetamol. And what you have in your house, not even shelf, in your house, is one paracetamol. A tablet contains 500 milligrams paracetamol. How many tablets will you give to the baby?
Half.
It's half now. Look at this person again. The strength is 250 milligrams. The patient needs 125 milligrams. How many tablets will you give? It's half. It's half. It's correct. Look at it now. The tablet itself you have at hand is contained. Listen, you have just listen. Stop what you are doing. The tablet you have at hand. This is the tablet. This is the strength of tablet you have in your hand. And the active ingredient there is what? 250 milligrams. But the patient needs 125 milligrams of that active ingredient. How many tablets will you give the patient to be able to achieve 125 milligrams? How many? How many? It's half of it now. Just simply break this into two. Bam. So far, it was properly mixed during production. If you break it into two, there's this thing they call tablet cutter. Used to, and most tablets are scored. Have you heard of scored tablets? You don't even need tablet cutter. If the tablet is scored, you just hold it in that line and break it into two. You know, you've seen a scored tablet before?
Yes.
That line at the other side, right? Now, if you divide it like that, you get 125 milligrams. Just and once it is scored, it won't break like that. Where you don't have that issue is where that a tablet like that is not scored. In that case, now you start looking for tablet cutter, and which if you cut it, yes, but some the other half may break into pieces. You give the half that is intact. So the patient actually need how many tablets? Half tablets. Just say half what? Tablet. Okay? Okay? Or you can say 0.5. It's okay, no problem. Okay? Is it clear now?
Yes.
I don't blame you. Others, people. And a lot of people call this two. I understand, but if you this take question
And there will be milligram. That's
where? Here.
I don't understand.
Here. Okay. Let's set it as proportion. Look up. One tablet contains what? How many milligram? 250 milligram. Therefore, 125 milligram will be in how many tablets? We call it X. So 1 tab over X is equal to what? 250 milligram over what? 125 milligram. X is now equal to what? 1 tablet times what? 125 milligram over what? 250 milligram. Milligram will do what? Of a tablet. So divide 125 divided by 50 is what? 0.5. So it's half what? Tablets. I think our time we spend more 6 minutes more, but it's okay. I think. Do you have any question? We'll stop here for today. Any question?
No.
All right. In the absence of any question, I think we'll stop here for today. Thank you very much. Please, before you come to the next class, try to arrange yourself so that you don't waste time. As you come, you just the sheet. The time you use to search for question is waste time. So before you come, just arrange questions. Pile it up so we can. We solve this one, we enter another one, and we take it up like that. Anyone we don't know, we look it up. That's why it's a review. All right. Thank you very much for your attention. God bless you.